Hello and welcome back to Getting Started with BGFX. So in this video we are going to be making a very basic renderer class. We're going to be moving all of our existing code into it and we're going to be using it. This is just to tie up our code and to make it easier for us to draw additional things in the future. So without further ado, let's dive right in. So if we dive into our project, our first thing to do is to create a header file. So we will right click on header files filter, create a new item. We'll call this renderer.h. Alright, go pragma once so that our file is only included once. Now let's start moving code over. So the first thing to do is we want all this stuff here. So actually we can just cut it, paste it. Then we want to include the image and our shader. So I'll cut that over. Then we want the screen width and height. So I want that, and we also want our matrix structure. So I'll copy that over too. Oh, sorry, not matrix structure, vertex structure. Alright, so the next thing to do is we are going to create a render batch. So I'll create it and then I'll explain what it is. So struct render batch glm mat for transform. Then we'll have BGFX texture handle texture. Spell texture correctly. Then we've got uint32_t start index, and then uint32t_t number of indices. And that is meant to be uint. Alright, so every time we submit a quad to be drawn, it will create a new render batch. So the render batch will have the transform matrix, the texture that we're using for this particular quad. It could be our own texture that we're supplying, or the white texture if we just want to draw a plain old color quad, and the start index. So the start index is where in the index buffer this particular quad will start, because we'll batch all of the vertices together in one big vertex buffer. We'll submit that to the GPU and we'll submit the index buffer along with it. So this start index tells the GPU where in the index buffer this quad will start and how many indices we want to use. Now most of the time we only want 6 indices because it's just an ordinary quad, but when we get to the draw text, we also want the number of indices will increase because we'll be batching a whole bunch of quads together. So what is a transform matrix? Well, a matrix is a mathematical tool that's used to convert a vector from one coordinate system to another. And if you'll recall from a previous video, the purpose of the vertex shader is used to convert the position from the game's world coordinate system to the GPU's clip space. And it uses 3 matrices to do that. The first one is the transform matrix. So the transform matrix has information about where the shape is positioned in our game world, its rotation, and its scale. The second one is the view matrix. This has information about where the game camera is positioned, what it's looking at, and which direction is up. So in our game world, up is the positive Y direction. And then finally, it has the projection matrix. So a projection matrix comes in 2 types. You've got the perspective and you've got orthographic. Perspective is used in 3D. and it's used to make our game world look closer to reality. So if you look down a very long road or railway, and you'll notice that it gets narrower as it goes off into the distance. To achieve that effect, you use a perspective matrix. An orthographic matrix, on the other hand, is used for 2D, and it doesn't matter how far off into the distance our object is, it'll always stay the same size. But both those types, they tell the GPU how much of the game world we can see. Alright, next we'll create the renderer class itself. So class renderer. We'll create the constructor. Then we'll have an initialize function which will take in our window. Then we'll have a begin function. So this begin function will be called every frame, and it will just reset all of the drawing, all the rendering. Alright, then we'll have a draw quad. So this is just drawing an ordinary colored quad or square. So first we'll take in a position, it'll take in a rotation, it'll take in a color, and it'll also take in a scale. Now, even though this is only 2D, we'll still take in Vec3 because that's just how it's calculated. And we'll do a draw image, exactly the same as the one above, except we will take in an image, a pointer to it. So again, we'll take in the position, rotation. We won't take in scale, but instead we'll just take in the color. Alright, render, so this will draw everything, and of course we'll need a shutdown function. Alright, we'll do the private variables now. Okay, first we want the index buffer. So we'll grab the handle here. Oops, it's meant to be an underscore. We'll grab the vertex layout. And then we will have the vertex buffer. Wherever that's ended up, there it is. Now, instead of just a plain old vertex buffer, this is going to be a dynamic vertex buffer. So, here's my dynamic. Dynamic. There you go, dynamic vertex buffer. So, a dynamic vertex buffer means it can be updated every frame, and that's what we want, because earlier in our code we are only drawing just the one quad. We knew it was going to be one quad every frame, but for this renderer class, could be any number of quads. Could be 0, could be 100. So we need to update the vertex buffer on the GPU every frame, and that's what a dynamic vertex buffer handle does. An ordinary vertex buffer can't be updated. Alright, next we need the uniform handle so that we can set the texture inside the shader. Uniform. Then we need our white texture, so this is used for when we want to draw colored quads. We'll need the shader program. Okay, now what we're going to do is create a vector, which means we need to include vector at the top here. So create a vector of vertices. So every time we every time we call this draw quad or draw index, it will put vertices inside this vector, and inside the render function it will take all these vertices, it will put them onto the vertex buffer inside the GPU. Okay, next we need to create render batches, a vector of render batches. Now we'll create a few variables. The first one is called m_at. So this is the position of our what the game camera is looking at. Then we'll go vec3 m_camera. So this is our camera's position. Then we'll go mat4 mView. So this is the view matrix. So recall that the GPU takes in the transform, the view, and the projection matrix to transform our positions inside of our game world to the clip space that it uses. And then we'll create a mat4 m_projection. Alright, that's our header. Now let's create a source file. So new item, renderer.cpp. Okay, first thing to include is of course our renderer header. Then we'll include print, so we can print some error messages. Then we need to include a file called glm/GTC/type_pointer.hpp. And I'll show you what that is in a minute. So we'll go renderer, we'll create the constructor. So that's not going to have anything. Alright, now we'll create the initialize function. This will take in the window. Alright, we'll jump back into our main file and we'll find all of this here. So we want to take that and put it there. We'll remove that because we won't return. Alright, next what we'll do is we will create a vector of indices. So in our original code we only created 6 vertices, and this was enough to only draw one quad. What we're going to do is we are going to create enough vertices for us to draw 100 quads. So we'll do this in a for loop. (100). And then what we'll do is go indices.pushback 4 times index plus 3, and then we'll just copy this plus 2, and just for completeness sake just do plus 0, and then we'll copy all these again. We'll do plus 2 plus 1 and plus 0. So if you recall from here, the first vertex, the first index, sorry, is 3, then 2, then 0, and then this, then 2, then 1, then 0. So this is all on the first quad, but we want more. So this index keeps count of how many quads we have and how many quads we have. So on the first quad, index 0, it does 4 times 0, does plus 3, plus 2, plus 0, then plus 2, plus 1, plus 0. Then it goes on to index 1, so it does 4 times 1, plus 3, which is 4, and then 4 times 1 plus 2, which is 6, then 4 times 1, which is 4 times 1 plus 3 is 7, and plus 6, and then so on and so on. So this is how we can use a for loop to create a whole lot of indices for us, enough to draw 100 quads. So you can change that if you want. You can just change this number, go up to 1,000, 10,000, a million, however many you want. Alright, so now we create the index buffer, and we'll go BGFX create index buffer, and we'll copy it because this vector is going to be destroyed once this initialize function is finished. So we'll copy indices.data, then indices.size times 2. So if you recall, this copy takes in a pointer of where our data is located, and then it copies this amount, which is the number of bytes. So indices.size gives us the number of indices we just created, times 2, because 2 bytes per index, and it just copies that all over. Alright, so now we will just check if that's valid. This is going to be very unsafe because it won't do anything if this fails. Is valid. Could not create index buffer. Alright, next thing to do in our initialization is we'll create the vertex layout, which is this part. So we'll copy that, we'll cut it from there, from our main code, so vertex layout, done. Alright, next we will create our vertex buffer. So we can just go, we'll copy this. So we'll go vertex buffer. So we need to give it something. We'll call need to give it a pointer to where the data is going to be located. So vertices dot data. And we'll give it our vertex layout. And then rather than multiplying by 4, we need to multiply it by the vertices.size. So what we've done is we've created a dynamic vertex buffer, and we've given it the pointer to where our data is going to be located, and we've just given it an initial size. So it will always look for this at this location, at this pointer. But the size there's what we'll give it later on when we update it. Okay, now we'll need to again check if it's valid. Okay, vertex buffer. Alright, we'll copy over the code that we used to create the uniform. We can also check it's valid. Then we'll copy over the code for the used to create the white texture. And we can also check if it's, the image will check if it's valid. Alright, we'll copy over the codes that we use to create our shader. And finally, we'll initialize the camera variables. So we'll do the camera position first. It's at X of 0, Y of 0, and Z of negative 1.0 F. And then we'll go what it's looking at. It is looking at the origin. Then we'll create the view matrices. So we need to call GLM look at. First we need to supply it with the camera position, so M underscore camera, what position it's looking at, as well as which way is up, so that is the positive Y direction. And finally we create the projection matrix. So we call GLM ortho and now we need to give it how wide how wide can we see, like what is the extents in all four directions, up, down, left, right. So you can see in the code completion we give it how far to the left we can see, how far to the right we can see, how far down and how far up we can see. So the left is screen width divided by 2. So this camera is going to be centered at the origin, and then screen width divided by 2.0. So bottom is going to be screen height divided by 2.0. Apologies, I'm just looking at my example. And then go negative screen height divided by 2.0 F. And now we need to give it near and far. So this is basically the clipping planes for the camera. Beyond these numbers here on the Z-axis, the camera won't be able to see it. So I just go 1000 in both directions. Alright, so that is the initialization. So now what we'll do is we'll create the begin function. So first we need to call the reset. So we'll give it the screen width, screen height. Need to give it the vsync. Then we'll clear the vertices. Then we'll clear the render batches. And we'll get these as well. So we'll cut them. And now we need to set the view transform. So BGFX set transform. Don't know why my IntelliSense is not working. And now we call GLM value underscore PTR M underscore view. And then we'll do the same again. So view transform, all that does is that it will set the view and the projection matrix for that particular view. So view 0 is the one we're using. So we'll set the view and the projection so that it will be used inside of our shader. And then we'll go BGFX touch 0 just in case nothing gets rendered. Alright, so what we'll do now is we will create our quad function. So we'll just copy that. Alright, first we create a render batch. Then we'll go batch.start index equals m underscore vertices dot size divided by 4 times 6. So where in the vertex buffer does this batch start? And then we'll give it the number of vertices that we're using. Not number of vertices, number of indices. So 6, that's how many indices we need to draw just one batch. Now we give it the texture. What happened there? Oh, I've called a white image. White image. There we go. Okay, then we need to set the transform. So this is a series of multiplications. First we'll call the translate. We'll go glm mat for 1.0f. So what this does, what this will do is create what's called an identity matrix, which is just a matrix that does nothing. If you multiply the matrix with a vector, you'll just get that vector straight out again. Alright, then we go position. Then we multiply it with the rotation, so we call rotate. And again we create a identity matrix. Now this works in radians. I've been caught by this many times. GLM works in radians, so we need to convert the rotation, which this is going to be in degrees. We need to convert it to radians, and also we need to tell it on what axis we're rotating. So that comes in the form of a vector 3, not 4, 3, 0.0, 0.0, f, 0.0 f, 1.0 f. That means we are rotating on the z axis, and it is vec3, not vector 3. Alright, now we multiply it by the scale. So we go multiply glm scale glm mat 4, again create another identity matrix, and we feed it the scale. So what all of this does is that it encodes the position, the rotation, and the scale into our transform matrix, and trust me, the GPU knows what to do with it. Alright, now we'll push this onto our batches, and then what we'll do is we'll push the vertices. So we'll go m underscore vertices dot push underscore back. First we'll create our position. So these quads are going to be 100 pixels wide. You can change it to whatever you want. I just make it 100 pixels wide, and then the scale will be applied to make it bigger or smaller or whatever. So negative 50.0, so the center is going to be right in the middle of the vertex. Give it the color and the texture coordinates. Alright, now to make it easier on ourselves, we'll just copy it 4 times. So we'll get rid of that negative, we'll make that 1. Then we'll get rid of that negative, we'll make that negative. That's going to be 1, 0. And then we'll make both of these negative, and that's going to be 0, 0. Alright, I promise we are nearly finished. How are we doing for time? Oh, 30 minutes. Alright, let's continue. So, the draw image is exactly the same as the quad. The only difference is that we don't have any scale information and we give it our own image. So we'll change that, get rid of the scale, and the image. Okay, so now what we'll do is we'll create our render function. So first we'll check if there are any vertices, and if there are, we'll call BGFX update go with our vertex buffer. Just check what 0 means, I can't remember. Of course not. Alright, but I know next what we'll do is we'll give it the reference to our vertices. Then vertices.size. Times the size of our vertex. And a semicolon. Okay, so what that does is every frame it will update our vertex buffer on the GPU with all the new vertices that we've supplied it in our vertices vector. Alright, now what we'll do is we'll go through each render batch. We'll make a reference to the render batch. First we will set the transform. So again we'll use the value pointer. So that sets the transform matrix inside of our shader. Then we set the vertex buffer. We need to set it every time because otherwise it will, oops, that needs to be a 0. Because every time we call the reset, and not every time we call the reset, but every time we submit, the vertex buffer gets cleared, and the same thing for the index buffer. index buffer, batch.startIndex, and then batch.number of indices. So you don't have to use the whole index buffer. You can tell it to start at a particular index and then use a certain number of indices. And then we call BGFX set texture. So in slot 0, and we use our uniform, and then we give it the texture. This means to be a dot. And then finally we'll call the submit of the view, shader program, and get the program handle, and we'll leave the depth for now. Okay, and then semicolon. Alright, now that we've done all that, we'll call the BGFX frame to render everything. And finally, we'll create our shutdown function. So we'll go back to our main code. And we'll cut all that. And m_index buffer, vertex buffer, delete shader program. I mean, I know I really should use something like a unique pointer or whatever, but I like to have more control over this. We don't have an image, but we do have the white image, and we do have a uniform. Alright, that is our very basic renderer class in its entirety. So let's use it. So let's go back to this. We'll include renderer.h. So this has the SDL headers, so we don't need that. So we don't need to include that here. And then we can get rid of all of this, and then we'll just create the renderer objects, and we'll give it, call the initialize function. Oops, accidentally deleted the create the window, didn't mean to do that. If you can hear that noise, that's the train. The railway is right outside my backyard. Alright, next thing to do is, what we'll do is we'll create a rotation. So we're going to rotate our quad. And we'll also want to create an image. So we need to do that after our initialization. So image equals new image, and I do not remember what it was called. It was called texture.jpg. Alright, rather than all of this, what we'll do is first we need to call our renderer.begin. First thing to do is we will draw a quad. We'll make this at 500, x of 500, y of 0, z of 0, and no rotation. And then we'll make this a, I can never remember what color this makes, and that's the alpha, and that's red and green, and we'll make this a little bit bigger. And then we will call our draw image. We'll give it the image. And that's going to be at x of 0, y of 200, and z of nothing. We'll give it the rotation. And we'll make it white. And we'll call the render function, and finally we will update the rotation. And just for completeness sake, yeah, 360 0F. And there's meant to be a comma in there. Okay, so what that little line does is they'll take the rotation and it will mod it, will take the modulus with 360, so that if it ticks over 360, so if it goes to like 361, then we'll just go back to 1, so that we never run out. And finally, at the end, I need to call the shutdown function. Right, that is a lot of code. Let's run it. Few warnings, we can ignore those. Oops, I think I know what happened there. Where is it? Nope, okay, not sure what happened, give me a moment. And I'm back. I swear it worked when I was creating this. Usually I'm better than this. So, a few things wrong. First up is, before we create the vertex buffer, first we need to resize the vertices vector. So 100. This is so that this vertex buffer has an initial size. So initial size of 100 vertices. That's enough for 100 vertices or 25 quads. It doesn't matter as long as you can give it some kind of initial size. Down here, this part, this describes the up, and currently our up is the positive Z direction, which is incorrect, so we changed that around. I'm sure a few of you are screaming at me. And then finally, this one is meant to be the opposite. So this means the bottom is negative Y, so it's down here, and this one is positive Y, which is up here. Now if we do that, we'll go back to the release mode, make those changes, and now we can finally see everything. We've got a nice yellow quad over here, and we've got a nice rotating image up here. So apologies for the long video. So that's it for this video. In the next video we are going to be making a frame buffer. So we'll look at what a frame buffer is, how do you create it, and what it's used for. So I'll see you in the next video.